Alright class, so I'm going to show you a vector graphics display today, and rather than show you a screen, we're going to look at this laser since I have so many of them lying around. And this one has some problems. It's really misaligned, so that's great actually for us because that means that I can open this up and show you all how it works. Now, of course, this isn't how vector graphics are drawn on your screens and your computer monitors, but I think it's a really excellent background into conceptualizing what happens behind the pixels. So last week we looked at how screens with LCD screens and OLED screens display pixels and how all the imagery gets mapped to that. But the math behind vector graphics is very different than the math behind pixel graphics or raster graphics. So even though ultimately everything on the screen gets rasterized, the way that we create vector graphics is a completely different paradigm. And so maybe in order to learn this paradigm, we might look at a display, this display right here. This is a laser projector, so like the projectors that we use to watch movies, it will project an image out, but it will only project a vector image out. So let's see how it works inside. And you see I'm wearing these goggles. These goggles are very cool. They're costume goggles, but the lenses that are on the inside are safety lenses. They're welding safety lenses that are not from a costume. It just happens to be that they fit into this frame, and like these are way cooler than the ones that I bought at the welding shop. But always wear safety goggles when opening a laser and looking at it. Okay, so let's see what happens. So I turned this on, but it's not doing anything yet, but I can kind of show you the paradigm inside. So here you see these two mirrors, two little mirrors on motors. We have the information being passed. So these cables literally pass the information of the location of each point of the vector to these motors. And these motors that have these mirrors, maybe we can get a good look this way. There we go. These motors that have these mirrors will move to a point on an XY grid that is sent to them via these actual cables. So the mathematical points that we plot in order to make our vector graphics are sent to these motors in space, and they move to that location. And of course we need to feed them with a beam of light as well, because they can move to the location, but if they're not reflecting anything, then what even are we doing? Alright, so on to the beams of light next. So here we are. I'm sending a very simple vector graphic to my laser projector. It's a square. Here you can see it again, a square. And you can see on the output right there, we have 4. You can even see where the line starts in the corner, the origin point. Then we have the next point where it makes the curve. And you can see on the green laser, better than the blue laser kind of looks like it curves, but the green one has kind of a sharp point where it goes down. And then there's the next point, and the one after that, and then it terminates at the spot where it started. Now this laser has a misalignment issue, but that's actually really great for us because you can also see the RGB. So here, the color is selected to white. Yes, it shows it in the square. Okay, so here it is. It's selected to white. It's selected to white, and over there you can see that all 3 colors are turned on. And now, if you remember your color theory, I can select, for example, cyan, which is a mixture of green and blue. So I'll select cyan. There it is. And if we look at the resulting image, we have green and blue turned on. So this is how vector graphics, well, in this particular device, mix colors. So if I turn on orange, you can see red and green turn on. And then finally, let's do purple, just so you know. Purple, and that'll show us green, no, sorry, blue and red. Fantastic. Okay, so here you can see the two laser lights are coming, two laser beams are coming out of these two lasers right here, and then they're going to the mirrors. And you can see the mirrors are vibrating slightly in order to draw those 4 points over and over again. And then if we look up here, we see our box. Pretty cool. Okay, and the other thing that we see is that the overlap between the colors is not perfect, and that's why we're not getting purple. We're just seeing the two colors on. So now we're going to pivot the mirrors so that we have perfect overlap. So in the case of a pixel, the color is embedded in a single point. The red and blue and green are embedded in a single point space, or close enough to a point that it fools our eyes. But here we have distinct shapes every time for each color, and so we're going to adjust them. Alright, I've set my output color back to white so that I can see all three of my lasers. And now I'm going to pivot the mirrors with this. There's a special hexagonal shaped screw in front of each mirror, and I'm going to pivot them until they all align. And remember to wear your safety goggles when you do this. Okay, so now you can see that we've aligned our beams on the y-axis, or sorry, on the x-axis. So now you can see that we've aligned our beams on the x-axis, and this translates very simply to here. We have these little screws in front of the mirror, of the optic, and this pushes the mirror backwards and forwards. So that's the x-axis. And then we have this little screw going into the surface of the mirror, and that pushes it up and down. So I'm going to adjust that now. So here you can actually see the point moving along to trace the vector. So you can see the scan rate of the vector. The point is moving round and round, and that's the flashy kind of line moving segment that you get there.